Hey everyone, we just finished our demo on access lists, and it's time for us to really start talking about how we're going to bring all of this together in order to allow our network to be able to access the internet. That's the primary goal here. We've talked about default routes, we've talked about static routes, we've talked about static default routes, we've talked about all of the elements to include access lists, because one of the things that we're going to need to employ in order to be able to allow our devices to have access to the outside world is something called a network address translation. And we need to know something about access lists, not everything, at this particular juncture, so that we can at least understand how we're going to be able to use access lists to control which prefixes will and will not be NATed in our infrastructure. So let's dive into a conversation about what's involved in enabling internet connectivity in our infrastructure. Well, first of all, we have to understand that we have a point of demarcation. What is demarcation? Demarcation is an end of the responsibility of the service provider. The service provider is going to put a jack on our wall. It's going to be a smart jack. It's going to be a DSL connection. It's going to be a cable modem or a DSL modem that's going to give us an Ethernet connection. Or it could even be a wireless solution or fiber optics. It just depends on the service contract that we have with the service provider. But the main point here is that where that equipment ends and they hand us that Category 5 cable or that serial interface, that's where their level of demarcation ends. So from that cable into our equipment, it's our responsibility. From that cable out, it's the ISP's responsibility. So it's going to fall into the categories of our DSL modem, our cable modem, CSU, DSUs if we're using T1s. But the main idea here is there's a logical point where the service provider is no longer responsible for the service. Now, if we want to bring devices on our infrastructure, we've talked about the manual application of IP addresses. The problem is that can be very, very burdensome, and it can also be problematic to us. Cisco extends us a capability in the confines of both our routers and our switches, which is a service called DHCP, Dynamic Host Configuration Protocol. Now, when we look at DHCP, what we need to recognize here is that we're going to have a machine, typically a server, in our infrastructure. But an important thing to realize is this could be a router or it could be a switch. And what's going to happen is as devices come onto our infrastructure, they're going to ask for logical addresses that are going to fall in the network that they're on the segment on. And what it's going to do, this entire range of addresses are going to be issued. This process is a client where the end device is the client and the server is whatever device is issuing the IP addresses. And what we're going to do is we're going to actually allocate those network addresses as well as other configurations such as our gateway, our default gateway, or gateway last resort, however you want to be able to designate it. And the thing here is the client host is going to actually request IP addresses, and those addresses will be sent to the end device, and it's going to apply those interfaces or those addresses onto its interfaces itself. So DHCP is very, very handy with regard to minimizing the amount of effort we as administrators have to go through to set the system up. Now, what we need to recognize here is DHCP gives us the capability of being able to allocate these interfaces using different fashions. For instance, we can use automatic allocation, where what's going to happen here is a permanent IP address is going to be assigned to a client. We have dynamic allocation, where we're going to get IP addresses, but we're only going to use them for a limited time. The last element here is going to be manual allocation, and what's going to happen is we're going to say the client is going to be assigned an IP address by the network administrator. So that's the way we've been doing things to date. I go under the interface, I apply an IP address, and everything's good to go. Now, the recommendation here is that we would never want to employ DHCP on the infrastructure of our network. Towards the clients, definitely it's something that we're going to want to be able to implement, but never would we ever possibly want to use this on the inside of our network with regard to our interconnections and our infrastructures. Now, when we look at DHCP, one of the whole things here is that we can configure a provider-assigned IP address. That's the main goal. And like I said, it could be statically assigned or dynamically assigned through DHCP. Well, Terry, you said that we didn't want to statically define, right? No, I said that I did not want to manually assign IP addresses. I can go into my server and say the MAC address of all A's should be issued a specific address. That address could be 192.168.0.12. based on that MAC address, and that assignment's going to take place. Or we can use it to operate purely through a dynamic process, whereby the system is going to ask for an IP address, the server is going to give it an IP address, the IP address will be adopted, and what's going to end up happening, 9 times out of 10, it's going to be set up on a lease, which means that IP address is going to expire after a certain time because their lease is going to run out. Typically, the ideal configuration is in 24 hours. Now, the idea with this is that if something were to happen and this PC that has this IP address of .12 should be compromised, what ends up happening is that when it releases its IP and gets another one, that's going to make it problematic for some type of cyber attacker to be able to leverage the device because the IP address has actually changed. Now, in the confines of doing this, we have this idea of a static provider address. Now, I can come in and I can do this through the application of the physical address under the interface, and I can specify what I'm going to use for my default gateway, i.e., this would be my router, and whatever is on the end to connect to here is going to be what I use to create my default route. Now we've already seen this done because I used the 0.0.0.0 space 0.0.0.0 previously in a config to be able to overcome a minor issue. Now the other part here is if we want to configure DHCP. So if I want a device to get a DHCP address, I go to the interface and I type IP address DHCP. That's going to tell the system that it needs to do whatever's necessary to communicate with whichever DHCP server we have in our infrastructure that's going to provide services. Now we've got a problem here. We'll look at that problem here very shortly. But the main thing is I want to come to terms with the exact process that's going to take place. Because the moment we start looking at this, we need to realize something. And that is that we have the class of addresses that we have, Class A, Class B, and Class C, but we also have different reserved ranges inside of each of those. And they're going to fall in the category of public addresses and private addresses. Our private addresses are going to be addresses that we can use on the inside of our network to be able to set up all of the hosts that we need without having to contact a numbers authority, without having to pay for ranges or networks of IP addresses. And we can use these because they are supposed to be not routed across the internet. The main goal here is that what we do is recognizing these ranges. So unfortunately, the only way that you're going to be able to do this is to memorize these values. So 1 to 9 is going to be a public range. My private range is going to be 10.0.0.0 all the way down to 10.255.255.255 in the Class A. In the Class B, it's going to be 172.16.0.0 all the way up to 172.31.255.255, and in the confines of our Class C addresses, it's going to be this entire range here where we have 192.168, and the last 4 octets are going to be available for the issuance of IP addresses or hosts. And we can also subcategorize this into the number of hosts that we want to support. But the main idea here is this is going to be something that you're going to need to memorize, and it's not anything that I can show you how to extrapolate. So that becomes pretty important for us. Now, the other thing that we need to realize here is that we need to understand how we can communicate to the outside world. And one of the main things that we need to understand here is that we just described 2 types of addresses. We have addresses that are private, which means they do not get translated or sent across the internet. And we have addresses that are public, which means they're built specifically to be used on the internet. So what ends up happening is that we run into a scenario where we may be using an address range that's going to be in the reserved range for our private addresses. So the question is if I have a device all the way out here that's running a public address, how do I communicate with it? Well, I communicate with it through this concept of NAT. NAT stands for Network Address Translation. Now, network address translation says, well, what I need to do is, first of all, I need to contact a numbers authority. So typically my ISP. My ISP is going to say, okay, we're going to give you an IP address that you're going to put on this side of your router. This is referred to as my global address. Any of these reserved addresses are referred to as my local addresses. Now what we have to recognize is that the person that we're connecting to, they also have a global address that's public. So if this was a server, so www that we're trying to communicate with. Now we're going to put this packet together and we're going to send it out, and the problem is that if I sourced it from 10.1.1.100 and sent it to the internet, this device is never going to know how to respond to it because it's going to have no reference to this private address. So what we're going to want to do is we're going to want to manipulate the behavior of our router such that our router is going to take this address and replace it with an address that's going to be reachable from the outside world. That's going to be our global address that we were assigned by our service provider. But there's another element that I want to make certain that we illustrate here, because everything about NAT falls into two purviews. We have the idea of inside and outside. So here we have inside. Here we have outside. Now here's the definition. All right, I have an inside local address, and believe it or not, I have an inside global address. Now what this word inside means, the way I want you to remember it is I want you to think of the fact that it's inside our domain of control. Yes, the service provider gave me the address that I have assigned here on my WAN port, but guess what? I don't have to use that one. I could use any other one that I may be issued from another numbers authority, or they may give me 10 addresses and I just chose to use that one. So it's going to be inside my control because I can choose to add it, to remove it, to control it. So inside means it's inside my administrative control. Now this guy over here has a global address also. But the point is that this is going to be, from my point of view, an outside global address. It's a global address, which means it's going to be reachable. It's public. However, it's outside of my control, so I can't do anything to manipulate it and work with it. Now, inside my control, I have the capability of doing some swapping. Because remember, we talked about the idea that when we send IP traffic, we have a source IP address, we have a destination IP address. So in this scenario, my source IP address was going to be 10.1.1.100. My destination IP address is going to be 209.165.201.5. Now the problem is this is a public address, but this is a private address. So when this device, if it were to get over here and this device tries to send me my response back, it's not going to know how to reach this address. That's where network address translation comes in. The moment I start using NAT, what I'm going to do is I can actually change the contents of my header. So let's look at it like this. What would happen if I took this IP address right here and I replaced it with the IP address that the service provider gave me? That service provider address may be something like 209.164.100.40. So using NAT, what I'm going to do is I'm going to translate my private address to a public address that's physically assigned to my device. And what I'm going to do is I'm going to make a record. I'm going to make a note that says I translated 10.1.100 to 209.164.100.40. And then I'm going to send that on its merry way. Well, when it arrives here on this device, the device is going to send me the information that I have asked for, and it's going to come across. And what's going to happen is this router is going to see, oh, I have traffic coming from this device, from .5, destined to this prefix or to this network. So what's going to happen is the system is going to look at the NAT table, the address translation table, and it's going to say, oh, I changed that, so it's going to replace this with this address, and then it's going to forward it on. So as you can see in this scenario, the network address translation process running on this router is transparent to everyone. But what we're doing is we're picking traffic that we're going to move and we're going to manipulate. We can actually match it on the source or the destination. We can do the inside source, the outside source. We can even do some fancy manipulations, like for instance, we can do NAT on a stick and things along those lines. So we'll be talking about a lot of stuff as we go through our conversions and our configurations in the confines of CCNA. Now, when we look at NATing, So first of all, we have this idea of the types of addresses that I just described. Of the ones that I want you guys to know for the CCNA, you need to pay attention to the inside local and the inside global. So if I have my router, and I have my connection going to my local network, where I'm going to be running my private addresses, what's going to end up happening is this is going to be my inside local address. Now also, the service provider gave me an IP address that I did affix to the outside WAN-facing section, wide area network-facing section of my router. This is going to be my inside global address. So all I'm going to do is I'm going to take any of my private information, I'm going to replace it temporarily with my inside global address, and I'm going to send it on. As traffic comes back in, I'm going to reverse the process, and I'm going to replace the inside global address with my inside local address. If I have an HTTP server or any type of device out here that's got an address affixed to it, that is considered an outside global address. Now that address is not inside my control, therefore it's considered to be outside. Now when I go through and I start doing my manipulations, this is what I see here. Inside local are hosts connected to my inside network, typically using private addresses. My inside global's usually been assigned to me by the ISP, and it allows the customer outside access. So I can go through here using this IP address and I can get out. The outside global address is going to be an address assigned by another numbers authority to another device that's outside of my control. We're also going to understand or have to realize that there's also a concept called an outside local address, which means that this guy over here is also running NAT on his network, so I've got NAT on both ends of the equation. So, but for the purposes of CCNA, what we need to know is inside local, inside global, and outside global. Now, all of this boils down to what's necessary in order to bring up our infrastructure and make things work. So when we look at this, there are different types of network address translation that we can employ. And what we also need to understand is that if we do this, we need to recognize the fact that we have to have either multiple addresses that we can source information or change it to, or we're only going to have one person able to connect to the internet at a time. So in this scenario, if my router has two IP addresses assigned to its WAN-facing interface, or a pool of addresses, I can have, or if I have one and two addresses, I can only have two simultaneous pieces of communication going on. Now what we see here is this is that NAT table. It's saying my inside local address of 10.1.1.100 was actually changed to 192.165.201.5. This one was changed to .6. And as we get information back, what's going to happen is when information arrives to this address, the system is going to reverse that process and replace the 209.165.201.5 with the 10.1.1.100 because it's going to know that it has to go back to this interface. That's going to be that whole idea of this being a one-to-one process. However, one-to-one processes became problematic because one of the reasons that we had private network interfaces or private addresses was so that we didn't have to have one public address that we paid for every device. In a one-to-one scenario, if I have 50 people on the inside of the network and I want to communicate to the outside, I'm going to need 50 IP addresses on the outside-facing WAN port of my router. So there's no real payoff for me in those regards. But what we need to do is really step in here and start taking a look at what's happening from the point of view of NAT, because they address this by changing the types of NAT. There are predominantly considered three flavors in network address translation. There's going to be static NAT, that idea of one-to-one. So for one device, I need one IP prefix that's going to allow me to go out that is a local private to a local global, an inside global interface that's going to be routable or public. The other concept here is dynamic NAT. Dynamic NAT allows me to have many-to-many. So what ends up happening here is I can create a pool. So where in static NAT I can say, okay, this one guy can communicate to the internet and that's it. Now what I can do is I can use dynamic NAT where I can define a pool of addresses and I can say, well, I've got 5 of these and I may have 50 people on my internet, but so long as I only have 5 IP addresses facing out, I can only have 5 users simultaneously connecting to the internet. That being many to many. It's not all to one. Now that's going to be the other idea. Many to one is this concept that we see right here called PAT. PAT stands for Port Address Translation Protocol. And Port Address Translation Protocol uses a capability inside of NAT to take all of our communication and wiring it to one IP address. And we do it by doing port manipulations. So let's take a look at exactly what's happening here. In the scenario with regard to static NAT, in this situation with a static NAT, if I only have one IP address that's outside, that means I can only have one device in my infrastructure that's able to communicate to the internet. So it's going to be whoever I've set it up because it's static. It's been statically assigned. So I create an entry that says anything that's coming from 10.1.1.100, change its address to this, and it's going to be sent to this particular outside global address. So we see inside local, inside global, outside global. So in this scenario, I have the capability of being able to come from the inside of my network to the outside of my network, but it's only going to support one of these guys that I statically configured. Now that's a pain. So one of the things that we used or do to overcome that is we move to a concept called dynamic NATing. But when we do a configuration on static NATing, the idea is that we have to configure it. It's static because we're going to do it on a case-by-case basis, one by one for every outward-facing interface that we have. So here, notice what we have. We have the fact that we're going to G01. That's facing outside of our infrastructure. We give it the IP address that we have. This is the inside global address that was given to us by the service provider. We specify that it's an outside-facing interface by saying IP NAT in outside. Then what we end up doing is we need to configure the inside-facing variables. So here, anything coming inside is going to be using gigabit 00. So here we say gigabit 00, and what we do is give it its IP address, which is going to be a private address, and then we say IP NAT inside. Now the magic happens down here. The magic happens when we start doing the configuration and we specify IP NAT, and what we're going to do is we're going to change the inside source address, and we're going to change it using a static map. And all we're going to do is say any device that has the IP address of 10.1.1.2, we're going to change its IP address to 209.165.201.5. Now, that's actually illustrated wrong on the drawing. This should be 5. And that's going to be a 1-to-1 NAT, and it's static because of this command right here. And we use the keyword static. So it should come as no surprise that it's a static configuration. We can also look here and say we're NATing the inside source address to something else. So the inside source addressing more often than not is going to be an IP address that's private. So we're going to NAT it to an IP address that's going to be public, and then we're going to send it on its merry way and allow it to go to the other device that we're trying to communicate with, or the internet at large. Now, how do we verify this process? Well, we use the command show IP NAT translations. And what this is going to do is it's going to give us the values that we configured. Notice it's saying here that the inside local address of 10.1.1.100 has been changed to the outside local address of 209.165.202.155. But that's not what it's been changed to. That's where it's going. We've actually changed the address to satisfy this value right here, which is going to be 209.165.201, and again, this should be 5. So this is what we've changed it to. So what we've done is we've replaced the inside local address, which was private, with our inside global address, which is public. And now we can actually send it to this information or to this device, and this device, wherever it is in our infrastructure, now has the capability of getting back to this IP address. The moment it arrives on this IP address, we're going to consult the NAT table, and we're going to say, oh, I'm going to change it back, and I'm going to replace 209.165.201.5 with 10.1.1.100. So as you can see, the process here is pretty straightforward with regard to configuring our NAT values. But the problem is like I said, it's that concept of one-to-one. So if I want 500 people to be able to get on the internet, I need to have 500 external IP addresses. Not going to work. So rapidly went away. So what was the solution? The solution was dynamic NATing. Dynamic NATing was a good solution, but again, we have a similar problem. Where we had static, which meant I had to one-to-one mapping, dynamic mapping gives me one-to-many. But it does not give me one-to-all. So if I have 10 IP addresses, located here on my inside global interface on my router, that means I can only have 10 users simultaneously accessing the internet. Now, that doesn't mean it's always the same 10, where in static configuration it is. The device that I translate statically is going to be the device that can always get on the internet. The way that I'm going to do this is I'm going to create a pool of addresses, and whoever comes to ask for an IP address for outside access is going to be served first. The moment my pool is exhausted, then I'm no longer going to be able to have people access the internet other than those that are already utilizing the service. So how do I configure NAT with a dynamic config? Well, what we do is we create a pool. And one of the things I want to look at here is the fact that we talked about ACLs, because I needed you to know a little bit about ACLs, because what I wanted you to do is I want you to understand that there's a security protocol here. We can create an access list defining the internal network that we want to be able to do NAT translation for. So notice here I have 10.1.1.0/24, basically 0.0.0.255. So this is that entire network, 10.1.1.0/24. So it's this entire network. So anything that's part of this network, I'm going to do NAT translation for. So what I'm going to do first of all is I'm going to set up my inside interface, my outside interface, IPNet inside, IPNet outside. I'm going to make certain that I have my proper IP addresses configured. And what I'm going to do is I'm going to create the pool. The pool is going to be the group of addresses that I have that I can use to support users. Notice in this scenario I have 5 IP addresses that are going to be inside global addresses. Now these inside global addresses are obviously useful to me, but I'm going to create this pool that's going to allow me to be able to say, well, that means I'm going to have up to 5 users on the inside of my infrastructure that can connect to the internet. The way that I do that is, again, I use IPNet inside source, because that's what we're changing, and I'm going to say use list 1 to identify the network devices that I'm going to do NAT address translation for, and what I want you to do is I want you to use the NAT pool that we created called NAT-pool. So the moment that's done, what ends up happening now is in this scenario, I get this many-to-one configuration. And I can verify this by again using the show IPNAT translations command here to be able to look at the actual output. And what we're going to see here is we've got several communications going out, but bear in mind, based on the way things operate in dynamic NATing, that means we have this idea of many to, or one-to-many style connections. So keep it, or many to many would, I guess, be the way through. It's not all. So bearing in mind, we can only support up to the maximum number of IP addresses that we have assigned to our pool. So Pat opened it up and changed all the rules. In fact, it's the easiest configuration that we're going to be doing in the context of network address translation. Pat says we're going to use one IP address and we're going to support all of the users inside of our network. How are we going to be able to do that? Well, we're going to be able to do that because we have the capacity of creating ports. Remember, we have this idea of IP source, IP destination, the IP port, and the destination IP port. So we have the source port and the destination port. All we're going to do is come up with some values that allow us to create unique numbers by taking the IP address and the port in combination, and that's going to allow us to have simultaneous users on the LAN side, in the inside of the network, using one IP to get outside. So it's going to be all to one. And again, what's going to end up happening is we're going to use these TCP port numbers to be able to do these manipulations. Notice now we have like 1723, 1723, connecting to 23. That's going to be the idea of telnet. So here, 1727, 1727, again, connecting via telnet. So the information that we're sending through means all of my users, if I have 500 users on my infrastructure, should be able to get out on that one IP address, making this probably the most versatile solution that we have available to us when it comes to using NAT to manipulate the behavior of our infrastructure. And the key thing about this is it's going to be identical to all of the other configurations except for one keyword, and the fact that what we're going to do is we're going to specify the interface where the outside or the inside global interface has been configured. So the inside global, which is going to be the outside facing interface as specified right here. And what we're going to do is we're going to execute the overload command. So it's going to be IPNAT inside source The same value here we had for the access list, which means we're going to NAT translate for these ideas over here on this one particular network. And we're going to translate it to whatever IP address has been assigned to this physical address. But the overload command tells us that we're going to use ports in order to be able to do that. So it's going to be through this concept of port address translation and the overload keyword that we're going to get the capability of being able to provide all of our users in our infrastructure with reliable access to the internet through our gateway of last resort or through our actual router, depending on how you want to be able to define it or describe it. So how do we configure this? Well, we want to verify it. And again, the verification is going to be the same as all the others. We're going to execute the show IP NAT translations command. And what we're going to do is we're going to look for those values that I were mentioning where we're going to have these these ports that are going to be indicative of like port 80. So the port 80 is HTTP. But notice here, whoops, notice on, I'll actually move myself out and bring myself back. Notice over here we have values that are going to be really high port ranges. These are called ephemeral ports, and that's going to be the fact that they're going to be randomly generated high values. And we can create a whole series of these, and through the combination of ephemeral port and an IP address, we can actually complete or create enough unique information for the devices to be able to maintain and to keep the integrity of the information that's being sent back and forth across our infrastructure. Now, as with all things, we have to recognize that nothing is ever 100% operational. So when it comes to actually troubleshooting our infrastructure and troubleshooting this idea of NAT, what we want to be able to do is we need to have some kind of guidelines. Now, just like all of the other illustrations, the key commands that we have were like the show IP NAT translations, show IP NAT statistics, and show access list. Because remember, we picked the network that we want to use to be able to use this ACL to say these are the guys or these are the particular interfaces that we want to, or networks, not networks, but hosts, that we want to do translation for. So what we're going to do is we have no connectivity to the outside. Well, if we don't have any way of getting to the internet, we only really have two possible scenarios. One is the translations actually taking place. So does the show IP NAT translations give us information? If they are, check the NAT ACL as identifying the correct traffic. So if they're not, then make sure that this access list is properly. Check to make sure that we have enough addresses in the pool if we're using dynamic NAT. Check that the inside and outside IP NAT configurations are correct. Remember, the outside faces the WAN or the internet, and the inside faces the local private addresses. So again, check that there's going to be traffic initiating the translation. So in other words, each of these guys must be generating something for the NAT process to take place. If all of that is occurring properly, we have a routing problem, and we need to be able to take a look at that. Are the translations occurring, but is there no connectivity? If yes, check that the remote router has a return route to the translated address. I mean, the whole reason that we're doing this is so that the remote router will have an address, but there still may be something going on the actual outbound component using our IP NAT configurations. And again, it's going to be incumbent upon us as administrators to modify and understand exactly what's happening. So these verification commands are pretty straightforward. Show IP NAT is going to give us the information with regard to the statistics. Notice here it's going to tell us the number of hits, the number of misses against the list, and it's also going to tell us how we're operating, whether we're dynamic, whether we're static, whether we're extended, all of those different values, and what interfaces have been configured as inside and outside. The other component here is to verify that access list. If the access list is not matching traffic, we're not going to do any type of NATing. Therefore, our entire configuration is not going to be operational. The other part of this is that we can execute a debug. We can use a debug IP NAT configuration. It's going to give us all of the information associated with all of the translations and any errors that actually may be taking place during the attempt to perform a translation. So bear in mind, again, when we start doing our troubleshooting, there are key elements that we really need to pay attention to. One of them is the fact that, like I said, the situation may occur where we're actually NATing, but the remote device may not have a way back. And that's going to make certain or require us to ensure that we know how to test the situation. So to verify that I have reachability to this IP address on this device, I would execute the show IP route. And then I would look to see if I have that actual interface or a way to get to that interface. In this instance, notice I'm using a static default route. So again, It really just boils down to how our infrastructure is actually deployed and how our systems are configured. So looking at exactly what's going on and how we set everything up, the prime tool that we're going to find that's available to us is going to be pings. Pings are going to test whether or not we have reachability in our infrastructure. We can generate pings from devices that are in the access list to ensure that we check the entire process for network address translation from beginning to end and vice versa. And we can even see where things are failing when we use that debug IP NAT command. So again, in a nutshell, we've covered everything that's going to be responsible, part and parcel of all of our duties to ensure that our network can actually get out to the internet. And now what we have is we have a functional environment through the judicious use of our static routes or our default static routes, our access lists, our NATing processes, and understanding exactly what's involved with our address ranges to include our local addresses that we're going to use that are typically going to be private in nature, which means they're not going to be forwarded or routed on the internet, and this idea of public reachable information and the necessity to be able to translate between the two. I hope this was really helpful, and I really want to make certain that you guys get the opportunity to review all of these processes. And I know I covered a lot of information, so you might want to actually rewatch this or any of the other videos again to make certain that we unlock anything that we may have missed in reviewing all of these processes. So with that said, I'll see you guys in the next lesson. Bye-bye.